Hi everybody, and welcome to Chem Talk, where today we will be going over accuracy and precision, and really clarifying the difference between these two concepts. So let's talk about it. A lot of people use the terms accurate and precise interchangeably, but they are actually not the same, and hold vastly different meanings in the science world. In short, accuracy is how close your results are to the expected or accurate outcome. Precision is how close your results from multiple trials are to one another. Both of these are crucial for executing successful laboratory experiments. First, why don't we take a look at a few examples of each. One of the most famous examples for these concepts is shooting a bow and arrow. Let's say you have 4 arrows and you shoot them. Now, the first step is to identify if the results are accurate, and to do that, we must identify what the expected or accurate outcome is. When looking at the target, the red bullseye is always the most accurate outcome. Taking a look, we can see that our results here are not accurate, as they are relatively far away from the accurate outcome. Now let's test if the results are precise. As mentioned before, in order for something to be precise, all the results must be relatively close to one another. Looking at the positioning of these arrows here, we can see they are all bunched up near one another. So this person shooting the arrows is a precise but not accurate shooter. Now let's look at another target. First, we identify the accepted outcome as the bullseye. This time we have arrows all near the bullseye, kind of scattered in a circle in it. We have determined our accepted outcome to be hitting the bullseye, and the person did this every time. So it can be said they were accurate. However, looking at how each arrow is a good bit away from the rest, it can also be said that this person was not precise. So in this case, they are accurate but not precise. Now, you might be wondering, why is it important to be precise and accurate? This can be understood by thinking about a laboratory experiment. Let's say a person is creating 3 identical concentration solutions of hydrochloric acid. They need to measure out 7.0 milliliters of 6.0 molar hydrochloric acid for each one. They end up with 3.50, 3.45, and 3.50 milliliters. In this case, the accurate outcome is the 7.0 milliliters. All of these trials are very close to one another, so the experimenter was being precise. However, they are not near the accurate or expected value of 7.0 milliliters, and thus not accurate. The person will end up with 3 fairly identical solutions, but none of them will be the accurate concentration the experimenter was trying to achieve. Now, let's say they redid the experiment, but this time ended up with measurements of 7.85, 6.85, and 7.05 milliliters. This time around, the experimenter was accurate, always getting a measurement close to the expected value of 7.0. However, they were not precise, as their measurements deviate quite a bit from one another. So this time, the experimenter will end up with solutions of concentrations all close to the expected or accurate value, but they will all be slightly different concentrations, not making them unidentical. It is best when a person is both accurate and precise. In a third trial, let's say the experimenter measured 7.01, 6.98, and 7.05 milliliters. All their results are very close to one another, making them precise, as well as very close to the accurate outcome of 7.0 milliliters, making them accurate. Now the experimenter will have identical solutions of the accurate concentration they wanted. This is why it is so important to be accurate and precise. Let's do one final practice. This time, pause the video between each example and try to answer yourself if the results are accurate, precise, both, or neither. An archer shoots 4 arrows at a target. They end up in the configuration depicted below. The accurate outcome is the bullseye. All the arrows are in the bullseye, and they are all nearly on top of one another, making this archer both precise and accurate. An experimenter is expecting a yield of product from an experiment of 2.00 grams. They mass their product and find it is 2.01 grams. The 2.01 grams is the accurate outcome. Our scientist here was able to get a mass very close to the 2.01 grams, making them accurate. But were they precise? The problem here is that only one trial was performed, because we have no other trials from the scientists to compare the results to. It cannot be concluded whether or not they were being precise. Let's try a longer word problem. In order for robbers to steal a bag of solid aluminum, they must correctly guess the mass of it and replace the bag with an object of the same weight. This is so they don't set off any alarms. Their guesses end up being 5.5, 5.3, and 5.1 grams. But then the robbers go to replace the aluminum, the alarm is triggered, and they're caught. When the police mass the aluminum, it turns out that it actually weighs 9.5 grams. This 9.5 grams would be the accurate outcome in this case. The robbers' guesses were fairly close together, so they were precise, yet their guesses were a good deal away from the accurate value, so they were not accurate. A student is playing horseshoe. Their tosses appear as depicted in the image, surrounding the goalpost. The accurate outcome is the goalpost. It can be seen that the horseshoes are all close to the accurate outcome, but far away from one another. This makes this scenario have accuracy but not precision. So, in conclusion and overall, accuracy is how close your results are to the expected or accurate outcome. Precision is how close your results are to one another, with multiple trials to compare them to. So that's all for today on accuracy and precision. Thank you for tuning into Chem Talk. Make sure to visit our website, www.chemistrytalk.org, for hundreds of general, organic, and biochemistry articles.